Hello everyone, this is Madhumati, Assistant Professor, Department of Food Technology, SNS College of Technology. So in this video, let's see about a non-thermal processing called the irradiation. So first of all, let's get into to know about the principle of food irradiation. So what is the principle? So food irradiation uses ionizing radiation. First of all, it will reduce the harmful microorganisms like bacteria and pests, and it does not make food radioactive. So it does not sustainably alter the taste, texture, or nutritional value of the food. Similar method as like pasteurization, it helps to prevent the foodborne illness and the spoilage. So this is the basic principle behind the food irradiation. So what are all the types of radiation sources that can be used for killing the microbes? So getting into that, there are three different types of radiation sources. The first one is the gamma rays and the electron beams and the X-rays. So the gamma rays is nothing but it is actually derived from the isotopes like the cobalt 60 or cesium, and the gamma rays will offer deep penetration that makes widely adopted for the various food products. So the electron beams, the E beams usage is high energy electron beams will provide an efficient, fast processing but have less penetration depth. That is more ideal for products that are more thin in nature. And X-rays are mainly generated by use of machine sources. They offer moderate penetration and are often used for bulk food items. That is to to deactivate the microbes for bulk food materials. And what about the dosage levels and how it can be applied? So, dosage levels mainly, these radiation doses are being categorized into three different types of dose, that is the low, medium and the high dose. So, in what manner we can, we can address these doses in terms of gray, that is like kilo gray, likewise we can address. So different radiation source, doses are being applied to achieve the main preset objective for the preservation of food. So low dose is nothing but that is up to 1 kilogram. We are calling it as a low dose. There it is actually used is to inactivate the insects and the mice, mites, and also to delay the sprouting process in the fruit or vegetable, or even the ripening process is also being used to delay in tropical fruits and the fiber crops. And the medium dose is nothing but it varies between 1 to 10 kilogram. So here they are more effective in reducing the microorganisms and pathogens that significantly helps to extend the shelf life of the items like the vegetables or the fruits or the spices. And third category is the high dose where it crosses above 10 gray. That helps to achieve a complete commercial sterility that is more essential for any specialized applications such as sterilizing the foods for immunocompromised patients or astronauts on long duration space missions. So these types of three different dose levels and where for what it is being applied is being given. Next, based on what the regulation or the the compliance standards, how it is being labeled. So whichever food is being treated with any non-thermal technique, that is, it has to be recognized with an FDA that helps to regulate the method. So FDA is a Food and the Drug Administration Act has to be passed so that it will approve specific radiation sources and permissible doses, and it is mandatory for during labeling we have to include the symbol. That symbol we call it as a radura, and like packaging materials must be approved for the radiation safety. So this is the overall concept map of food irradiation, how it is being carried out. So this is the concept map of food irradiation, like food irradiation, how it actually undergoes. First, we have to look into the benefits and the safety, then how much dosage levels and the types of radiations methods that can be introduced and how it is applied and how it can relate with the safety of the food. This is the overall concept map. So when we apply it with the design thinking concept. So first we have to emphasis on based on food safety. We have